Good morning all, welcome. I'm just going to wait for a few more people to arrive. So, welcome to another Spring Showcase. Today we are partnering with United Utilities and Datatecnics to find out how they have worked collaboratively to find innovative asset monitoring solutions. My name is Leah Bodley and I'm a Marketing and Communications Executive here at Spring Innovation. For those of you who might not already know, we are the Innovation Centre of Excellence for the water sector. We're supported by all of the water companies across the UK and Ireland, as well as the supply chain and academia. Our goal is to enable collaboration, remove duplication, and accelerate innovation within the water sector. Spring are custodians of the Water Innovation Strategy 2050. For anyone who hasn't seen that document, we will share a link to that in the chat. It lives on our website and it outlines 7 main themes with challenges sitting under those themes that we are currently trying to tackle in the sector. Spring also puts out calls for innovation against those themes through our Accelerator service. You can find out more about our Accelerator offering on our website, which we'll also put a link to in the chat. But today's service offering is all about knowledge sharing. We have 2 aspects to that. So the first is our knowledge library on our Spring platform, where there is a bank of over 60 case studies on innovation projects from across the sector for you to go and learn from. Recordings of our previous showcase events, as well as supporting links and documentations, also sit alongside these case studies. With another 200 case studies currently sitting in our pipeline, our platform is constantly being updated. So I really encourage you to head over and register for a free membership and check out our knowledge section. There will be a link to the chat in this also. I'd just like to give a warm welcome to our international audience today. We are thrilled to see registrations from India, Japan and Australia. So welcome to the call and thank you so much for joining us. Today, you can expect to gain insight into how the collaboration between United Utilities and Datatecnics began, how it's going now, and the exciting new avenues for predictive asset maintenance that have been explored as a result of it. These showcases are all about being able to learn a little bit more about the project and taking away those learnings and knowledge and being able to embed it in your organisation. With over 3,600 people registered for our events, we're really proud of how these events are helping to disseminate the vital knowledge surrounding water-based innovation and accelerate things across the sector. We'll be launching a poll at the end of this showcase to find out how interesting you found the session and also whether you're hoping to go away and use the information afterwards. So please do submit your answers at the end of the event when this comes through. You'll also get the chance to ask the project team any questions at the end of the session, so make sure to keep putting your queries in the chat throughout today's presentation. So on to today's session. I'm just going to run through the agenda and introduce our speakers before I hand over to them. So to begin, we are covering the importance of knowledge sharing in the water sector, the United Utilities Innovation Lab, Introduction to Datatecnics, the ambition, phase 1 towards digital mains, phase 2 building the ecosystem. We'll have a quick break and then we'll go into next generation asset management and our Q&A to finish. So today's speakers, we are joined by John Brown, Programme Manager of Innovation at United Utilities, Sahil Zulfikar, who is the CEO of Datatecnics, Steve Quarmby, who works in innovation at United Utilities, and Courtney Connor, who is Leakage Technical Manager at United Utilities. So that being said, I'll now hand over to John.
Thank you. Welcome everybody to lovely Lincolnmere in the northwest of England. So we're here today to really showcase some fantastic work that we've done over a reasonably long period, but as part of that long period, we've looked at a number of innovations across a number of problems. So we were really excited to be able to share this through the Spring platform today. So just a little bit about our company for those who don't know. We're a relatively large company. We're a FTSE 100 company based up here in the northwest. We work in a changing but regulated sector, and we have a continued focus on innovation, which is the space that we occupy. Why we're here today to talk to you about this innovative project, selection of projects. Now, over a number of years, we've been working in innovation and we've got a tried and tested innovation model. As part of our innovation model, we like to encourage people, we like to encourage suppliers, and also we really try and accelerate and adopt the great ideas that we've managed to test and trial and de-risk through our processes. But part of that, the reason why we're here today, is to share that story. So first of all, thank you to Spring for helping us platform this and be able to share this, not just in the Northwest, but all over the world. So thank you very much to the team at Spring for that. And as part of the work that we do, we have a number of methods and models and approaches that we take to innovation, because not all innovation is the same. So first of all, we work at a strategic level. So we work across the UK water industry. So we help support the 2050 water innovation work. And we've got quite a number of projects across the Ofwat innovation programme and competition. A little bit more close to home within the business, we have our Innovation 100 programme, which also includes our CEO Challenge, which you'll hear a little bit more about later on in the presentation on how that played a crucial role in the delivery of some of these projects. And finally, we have the Innovation Lab, one of our centrepiece programmes we do with Al Marks, and the purpose of the lab is to really accelerate ideas through a concerted collaborative effort. Now, a little bit about our purpose as a business. So we're here to try and make the Northwest stronger, greener, healthier, and better overall, which is our core purpose of what we do. But part of that, we have a number of strategic priorities, which you can see listed on the screen now. Across those strategic priorities, you'll see that we've highlighted a couple that really sing to this selection of projects that we're going to share with you today. Whilst they cover all of them, the two that are really impactful for the work we've done are around delivering great service for our customers and, importantly, spending customer money wisely. So how can we be effective in how we deliver things? How can we do more for less? How can we be really efficient? So this idea and suite of solutions really plays to that, because ultimately our purpose, our values go down to do the right thing, make it happen and be better. So this project and selection of people that we've collaborated with over the years has really brought all of this to life. So we're really pleased to be able to share that with you. What brought us to this? I mentioned it earlier, it's the lab. So our innovation lab, that purpose of that accelerate programme is to engage more people, to encourage new suppliers and accelerate adoption, and finally share the story. As you can see from the statistics, it's been really effective over the years that's been applied. There's been some great ideas that have come in. We've encouraged and connected to people all over the world. Even the recent lab, we had everyone from Chile to China connecting to us in our innovation lab. But in terms of what we'd really like to showcase today, there's a few really prominent ideas that have been successful through the lab process. We've got the likes of FIDO, we've got the likes of altitude thinking. But today we're talking to you about Datatecnics, which is a great example of co-creation and collaborative working on how we deliver innovation projects across the ecosystem of our UU model. Now, why do we want to talk about Datatecnics? Well, it all goes down to people. And we believe Datatecnics are a great example of open innovators. Now, we are an open innovation team, and we like to find open innovators to help us bring those mutual benefits. So what do we look for when we're looking for open innovators? We look for diversity of thought, we look for curiosity of mind, and a resilient doability that allows us to get over the problems. Because what we all do in this sector isn't easy, isn't forgiving, and can be quite challenging on a day-to-day basis. So what do? We work really hard on a few key things to make everyone else's lives a little bit easier and enable them to be successful. So we work hard on finding and persuading people with great ideas, such as Datatecnics. We spend a bit of time brokering and trying to test these ideas and de-risk them for the business. And then we work hard trying to get them adopted and optimised for what we do. But as an example of what we really want to do more of and work with Spring to promote more is share and endorse great ideas. So as part of today, we're here to share the story and journey that we've shared with Datatecnics so far and how we really want to promote that through the Spring platform. With no further ado, I'm going to hand you over to Sahel.
Thank you very much, John. Good morning, good afternoon, and hello to everybody joining from around the world. My name is Sahel. I'm the Chief Executive of Datatecnics. So, a little bit about Datatecnics to try and set the scene. The whole of our business is geared and focused around one very specific objective, and that's building the absolute best-in-class prediction models to help water companies understand what the condition and performance is of their infrastructure. And we've really been focusing on this mission since the very first day that the company set off, all the way back in 2017. And today we want to take you through the story of building Datatecnics, not just away in a little corner of the world, but with our customer and understanding what their pain points were in a collaborative manner. So we're really excited to share that with you today. A little bit about, I suppose, our team and what makes us unique. I think when you look out into the landscape today, understanding an infrastructure base, which is an infinitely complex task. Pipeline networks are very complex systems of pumps and valves and pipelines. And it takes a lot of engineering knowledge to understand how this buried system that is old, much of which has been in the ground since the Victorian era, how that all interacts with the newer pipe materials and the newer technologies that we've got. And so this team that we've built of water engineers and software engineers and data scientists and electronics engineers, they all work together to build these absolute best-in-class prediction models. And that really is what makes us very unique and allows us to solve very many different problems in the context of a water company. Today, we'll be taking you through 6 years of code development, and it's a real joy for me personally, as a chief executive of the company, to be here where really I started my own journey with UU. 6 years ago, we came here right to this very place and applied to the Innovation Lab. And just a few rooms over to my right, I actually was there pitching and hopefully wanting a place to get onto this fantastic program that we then became a part of. And so today I'm really excited to share with you what has resulted following the successful application to the Innovation Lab and how we've turned our product into what was a very simple proof of concept, if you like, a single product and a single ambition into a whole ecosystem of tools to help water companies around the world understand the performance and condition of their pipeline infrastructure. So I'm going to take you all the way back to why we set the business up in the first place. And our goal really was, how can we help water companies build the most robust understanding, the best possible knowledge of the health of their pipeline infrastructure? As I said, this infrastructure is buried. It's not easy to access. It's old in our developed economies. It's not newly laid, but our society is centrally reliant upon it. And water companies are desperate to understand exactly where the infrastructure is in terms of its remaining useful life. So helping water companies solve that problem was something that was really of central interest to us. And what we wanted to do by solving that problem was deliver the biggest possible reductions in water loss, but also make the biggest possible reduction to capital and operational inefficiency that would result in these massive savings to a water company's bottom line. And what I'm really energized by is that as we've made our way over the course of the last few years in accelerating towards that end, we've attained, and you'll see today, a remarkably comprehensive platform and one that adds a huge amount of value, both strategically and operationally. But the mindset at the start was very much, well, how do we tackle this really complex problem? There's so much to kind of try and resolve here. So many different pipe materials of so many different ages with so many interconnected pieces. And so we actually started with a thought experiment. We asked ourselves, what would be the value of providing a system, a platform, a knowledge base to a water company of exactly where a pipeline was going to fail and when it was going to fail? Why would that be useful? And I think that's kind of an interesting thing to think about, because it helps clarify some of the use cases to go after in the first case. And so what we realized was there was kind of this perfect allocation notion, or this just-in-time notion, that really drives predictive asset maintenance. If preventative asset maintenance is a fixed timescale for replacing something like a railway track after 30 years, a predictive asset maintenance timescale is about replacing and doing things just in time. And so if there's a perfect allocation of people to problems, if there's a perfect communication by the water company to its stakeholders, if there is a perfect delivery of capital, i.e. investing in exactly the right assets at exactly the right time, if there is a perfect operation of pumps and valves to get the absolute most out of them and to reduce bursts as absolutely as much as possible, this was the utopia that we were shooting for. And that was something that really energized us, because we knew that if we could deliver that, the range of efficiencies that could be generated, even by getting 50, 60% towards that objective, would be so tremendous and would so comprehensively move this sector forward that it was a worthwhile endeavor. And so in the bid towards that, we recognized that there were two levers that we were really pulling on. We were going to pull on the water efficiency lever and try and attain these megaliter reductions in water loss across an entire network. But also, we weren't targeting 1 million or tens of millions of pounds in reduction. We were targeting hundreds of millions of capital efficiency across an entire investment period, which here in England and Wales enterprise about 5 years. So we wanted to be ambitious right from the get-go. We wanted to build a holistic system for integrating knowledge across a water network and driving these efficiencies. And that was really the philosophy, the design philosophy. That was the ethos that we wanted to build with. It was an integrated platform which we needed to develop to monitor, model, and then optimize an entire network. And the interesting thing was we started out a period in which I don't think we're too far away from even today. You know, if you look at how we generate data on our infrastructure, we have individual suppliers who sell their kit. We have model suppliers who sell analytics, and then we have disparate UIs and visualization platforms. And we haven't yet, as a sector, quite figured out how to connect all of these things. Despite our water networks being connected systems, we now need a data architecture that equally represents that. And in the bid towards that, I think we knew that we would have to create this unified architecture. And so we have tried to advance as much as possible each of these individual strands. Not that Datatecnics would necessarily become the supplier of all of these individual components, but it was important for us to build an architecture which a water company could coalesce around, could push all of its high quality data into, with really powerful, really performant water engineering, domain expertise, refined models, and then have them represented in a single dashboard so that experts within a water company, SMEs, subject matter experts, were not having to go every which way in order to get the knowledge that they needed to. And so what I'm really excited by today is the story that we're going to take you through. And to start that journey for you is Steve Cornby of UU.
Thank you very much, Sahel. And what a fantastic and inspiring vision to start with. And of course, the issue then is how do we turn that vision into a reality? And we jointly determined that we do exactly that. So we actually made that happen through the Innovation Lab. As Sahel mentioned, Datatecnics applied to the Innovation Lab. They weren't the only applicant. There were hundreds and hundreds of very eager, very capable organisations out there who joined our lab, and they had to go through a very exacting process. Datatecnics got through that process because it was actually obviously a very sought after process, and the prize was to have a place on a curated accelerator lab with access to use physical assets, access to use data, access to use senior managers as well as our operators. So they actually pitched something for us that we'd never seen before, and that inspired us. That actually got us technically excited and filled our experts with enthusiasm, because it actually also landed with one of our drivers, which was our predictive asset maintenance embraced into our organisation. So we were presented with a pipe that was digitally intelligent. It actually had the capability to relay information from underground to the surface, so asset managers and operators could have real-time data on what's going on, something we've never had before, something that's actually quite out of this world when you think about it. And that intelligent sensor was actually intended to be embedded in the pipe, in the factory. That's the idea that was presented to us. That was out of this world. We respond to that by embracing Sahel and his team into the accelerator process. They joined us for an accelerated process and got the access to our capability, our staff. They have a site here. They were able to enjoy all the benefits of being in a large organisation. We were able to enjoy all the benefits of working with a dynamic, small, vibrant, but excited organisation with a mission and a passion and a new capability. So that capability was presented to us, and as part of the deal, we give them expertise. We give these people who come from outside our organisation, we give them insights into the water sector. So we get the value out of being given a new idea. We merge that with our knowledge and capability that we already have and see what comes from that. One of the outcomes from our exposure to our experts was they thought it was a great idea, great long-term idea. And then obviously they presented us with a challenge that actually, surely after 50 years, when we put this sensor in the pipe, it's only at that point that the real true value of that new sensor in the new pipe will start to accrue to us. What about if we could put similar sensors in existing pipes, old pipes, dilapidated pipes even, but pipes that are currently underground, we could get information about those pipes if we could retrofit this solution. So although we had originally received a new technology in a package of a new manufactured solution, we actually jointly explored the idea, does that really match the problem that the water sector currently has? So we decided to dissect the problem and reconstruct it and pivot our approach for the next sessions of the lab. So in summary, Datatecnics joined our lab, they opened us up to a new idea, we mutually evolved that idea into something, it demonstrated Datatecnics' flexibility, responsiveness and creativity, and in my opinion was a very worthwhile and excellent start. I'll now hand over to Zahel to continue with the story.
Thank you, Steve. So what was really exciting for us was we got feedback from the customer about what their pain point actually was. We weren't just off developing something, hoping that when we went to market that it would land. And what I'm so enthused by was that we were actually able to take our original smart pipe idea, which exactly correctly, as the feedback suggested, was a fantastic solution for some future point in time. But we had an issue with our asset base today. We have huge numbers of assets. You know, in a country alone, 50% of our assets are over 50 years old. And so there is a real need to understand what the rate of deterioration is of those assets. And a huge theme as we go through today's presentation will be data quality. And we wanted to get really high quality measurements on specific high criticality, high consequence of failure pipelines, and understand exactly what the rate of deterioration on those assets was, feed that back to you, and ultimately see if we could generate an entirely new measure of asset health for the whole of the sector on these critical mains, which didn't have a huge volume of high quality data, were historically zero fail, and when they failed caused sometimes quite catastrophic damage. And that's really what we adapted into this technology called Ground Truth, which is a multi-parameter monitoring system for the whole soil pipe environment, understanding not just how the hydraulics of the pipe impact the pipe itself, but also the ground, how that impacts the actual asset and how that impacts the deterioration of the asset over time. So what did we do? First thing was, I realized with my very small team at the time that we needed really deep water engineering expertise. And so we partnered with the Pennine Water Group at the University of Sheffield, one of the best water engineering universities anywhere in the world. And we rapidly converted our smart pipe idea into something that could be retrofitted and applied to existing pipe work. We then applied these sensors directly to the pipe wall, and we instrumented these pipes, and we worked with UU to identify a test facility. We then pressurized that pipe, and we were able to create hydraulic transient conditions, varying surge conditions inside of the pipe to stress it out in this test environment. And the results that we got back were really interesting. There is clearly a relationship of pressure to a parameter that we were monitoring called strain. So stresses that are imposed on a pipe result in strain. And one of the stresses is pressure, in addition to other stresses that a pipe will experience. And what was really interesting for us was that although there was a clear and natural relationship between pressure and strain, that it wasn't a one-to-one relationship, i.e. at some point, as you would pressurize the pipe, the strain would continually increase above and beyond the amount of pressure in terms of the magnitude that you are putting into that pipe. So it started to make us think, well, how valuable would this actually be as a metric? What could we do with this knowledge and this data? And that was something that we wanted to investigate further, because clearly this relationship between pressure and strain was important, but we needed to turn that into a really practical, usable metric, something that could be embedded within a water company context. And so we had a series of reflections after we had gone through the deployed period that was in and around, well, how would we introduce this into a real pipe network, and what impact would the soil, the ground loading actually have? Because we had modeled in an open air chamber, a brick built chamber, what the impact of the pressure would be on the pipe's strain, but we hadn't really understood what would happen when the soil would impact. And soil is one of the most important things to model, and is totally absent from pretty much all of our modeling, and certainly our sensor-based instrumentation. When we go out, we're really interested as a sector in what happens with the pressure internally or the flow, but we don't really do a lot with the ground movement, despite that having a great impact, as we know from freeze-thaw conditions. So we were interested in understanding that. We wanted to understand how the metric, as I say, can be integrated in a water company context. And then I think one of the other things that we were really keen to do was understand whether or not this metric could be augmented and enhanced in any way. So this was the path that set us off towards digital mains, and I'm now going to welcome back Steve to talk you through that journey.
Thanks once again, Zahel. That's great. So as part of the lab process, which you understand is an accelerator is by the very nature small scale, 3 months or so, but that's only to allow us to understand if this technology got legs, got capabilities, something to explore further. And of course, we can only do so much in a lab. We've got to commit to going to real world at some point, and that's exactly what we're committed to do. So we were invigorated by the idea. We were exposed to a cutting edge technology. The next step was to simply actually bite the bullet and put it into the real world. So we established a core team. We had obviously our UU systems and staff. We also engaged construction resource for 3 patches across our region to actually put this in real world, in real life conditions, to get exacting information that we needed to verify this and take it to the next stage. So this process was actually backed by our asset management director. We were financed by the innovation team. And the whole point was to actually get real world deployment. This involved digging in the highway, involved conflicting with services, liaising with local authorities. So as you can imagine, the planning had to be very precise, very meticulous. So we actually followed all our good governance and got the full buy-in to actually move on this, and got all our experts all aligned and all understanding what we were doing and why, and also understanding what the expectations were going to be and how we'd interpret the data. But we're on a journey of discovery, so who knows what we're going to discover at any particular point. But of course, we have to work within a governance framework, and that's exactly what we did. We wanted this to be real world. We wanted to abstract quality data from an underground asset in real world conditions, with Lewis going over it, with movements of the earth, with moisture changing depending when it's raining, and whether the seasons change the water condition of the soil. So it had to be in situ, and that asset understanding would also contribute to how we would take the next step of taking our journey along the path from reactive maintenance to proactive maintenance. We wanted to know what the true potential was of this capability, and that could only be done by constructing our first digitised main in real time. I'd now like to hand back over to Zahel, where he can pick up the actual mechanics of how that reality was brought to bear. Zahel?
Thank you so much, Steve. The backing from senior management at UU was really key, because ultimately we're deploying an entirely novel capability, and deploying that capability into a water company, taking on this entirely new parameter of strain, which has never really been modeled before. It's never really been integrated in a usable way. There's been lots of research done over the years in a water company context in this country and in Australia, but it's never actually been integrated. How do you use something like strain data, practically speaking? So to get buy-in from senior management was excellent, and it was really encouraging for us. And one of the immediate challenges that we faced from taking that small-scale prototype was, well, we're going to have to design this to operate in a mucky, wet hole, and it's going to have to survive several tons of soil that's going to be thrown back into the trench. We were going to compact the pipe again after the ground was reconsolidated. So the electronics had to have a certain resilience themselves, and that took a lot of working through. We had to think through pretty much every component of the electronic system right from the ground up. And this was really where the relationship with UU and the lab process that we had begun and then evolved was so essential, because if we didn't have that relationship with UU, we wouldn't have been able to resolve so many of the challenges that emerged during the electronics redesign process. And a good example of that is the usage of the boundary box. It was just such an organic and natural choice to put our electronics into what is standard street furniture for contractors. So that was a process that was certainly very collaborative. The next challenge that we had was building a metric that could actually predict remaining useful life of the asset over time. And for this, we had to deepen our relationship with the University of Sheffield and the Pennine Water Group. We had to extend our suite of experiments, and we actually had to start leaning into artificial intelligence techniques. So this is the first point at which our models start to really take on a life of their own, where we combine real-world multi-parameter sensor measurements with artificial intelligence for the sake of modeling asset health in this entirely new, entirely novel sense. And that was really exciting for us. The other thing that I think was particularly important is that you then have to start thinking quite practically about where this system is going to actually be deployed and where it will be most efficacious, i.e. where the business case will be most pronounced for the water company. So we had to think about all those critical mains. We had to think about critical crossings, particularly vulnerable material types, particular climate responsive areas, anywhere where this type of system could add a huge amount of value in terms of the knowledge that it would generate. And then finally, we selected the sites. So PVC was a particularly important material for UU to model. And that was the material that we picked. So every one of these 3 sites that we selected is a large diameter PVC main. And we were able to get out to site, and finally in 2020, we had selected the mains, we had worked with the contractors and submitted our RAMS process. We'd gone through all of the relevant health and safety processes. We had this amazing, resilient hardware that we could now deploy into this very challenging environment for those electronics. And we had also built out the cloud infrastructure, because these are fully IoT devices, to receive all of this data from these mains out in the field. And so finally, in 2020, after a whole year's work, we got out with all the energy and the enthusiasm in the world. I donned a high vis for the first time in my life and looked totally ridiculous. And we dug this hole based on the specifications that we had submitted to the contractor, who were brilliant. Network Plus were such a wonderful organization to work with. They worked alongside us to dig the holes, and then equally their subcontractor JMK. So we were working with multiple parties. We were working with UU. We were defining the size of the hole. We worked and got into the trench, where we managed to expose the pipe as we needed to, and then actually apply our sensors to them as well, and bond those sensors in a way that was going to allow us to take the measurements that we needed to on the expansion and the contraction of the pipe. We finally sealed everything off, and no sooner had we got going than COVID came along. That was really fun to deal with. March 2020 was a challenging period for the whole world, and equally for us, we went into a phase where we couldn't carry on. All of this work that we had put in collaboratively and collectively had to come to a pause. And I think this is a period where relationships, when indeed, the relationship with UU really mattered and counted. We needed a patient, responsive, committed, collaborative partner. And UU were all of those things and then some. They were really committed to continuing to work with us, to work through this challenging period. And whenever we could, when the restrictions eased and it was legal to do so, we then got back into to do the deployments and finalize the installation. And so I'm really pleased to say that in March 2021, despite the challenges that we faced and the patience that we all had, we actually managed to bring our 3rd main online. And that was a really exciting period for us. Definitely stop-start, but fundamentally we got done what we needed to get done. And here's one more ridiculous photo of me in high vis. But as you can see, it was a huge, hugely exciting period for all of us, and we were really pleased to bring all of these mains back online. Now, what I'm going to do is I'm going to pass back over to Steve, and he's going to walk you through some of the data that we saw when we did.
Thanks, Sir. So actually, the story so far is that we've gone from a theoretical application to an innovation lab. Going through that lab, proving the process, proving the technology, and actually now going out into the real world where the muck and bullets are, as I just mentioned earlier. And above and beyond all the construction activity that's taking place, which is itself a handful, we actually had some good luck and some bad luck. Now, projects always generate luck. I don't know about yours, but mine always seem to generate more on the bad luck than any others. And that's just the way things are. But on this particular project, we had the most immeasurable piece of remarkable good luck. On an asset that was completely unrelated, completely detached and physically remote from our sensor, a collapse happened. Now, just going back a step, our sensor had been installed on a water pipe many months earlier and had been generating conspicuous amounts of data for quite some while, and it was allowing us to understand ground movement and settlements and actually getting the data organised and understanding what that data was telling us and discriminating against any background noise and such like. So it was doing its job. Well, on the 2nd of October, we got a signal from visitors. We got residents saying there's a big hole on a green outside our houses. What have you done about it? And of course, because we were the last to have been there, we immediately got the blame. So that hole must have been caused by us, logically. No, that hole was caused by a completely unrelated asset. We just happened to be in the vicinity, but what a godsend that was, because within that vicinity, we were picking up data not only from the pipe, but from the vicinity itself, from the immediate surroundings. The sensor was so sensitive, it was able to pick up not only pipe movements and pipe stresses and pipe strains, but actually information about the wider environment, many, many meters around it, many, many meters around it. The data itself was discriminated and filtered out, but of course at the time we didn't know that. So on the 2nd of October, which is little blue dots on the graph that you can see there, that's when we were told by residents there's a hole in the ground. When we looked at our data set, we found we got signals, strong signals from the sensor buried on our water pipe that something had happened to a completely different asset meters and meters away that we'd had no impact on whatsoever. There'd been no construction impact whatsoever, but that a spontaneous sewer collapse just happened to take place while we had an innovation project in that area. When we look back at that data and reconciled that data, it was conspicuously clear that signals, clear signals, had been generated 2 weeks before any human being had even detected there'd been a problem. So if you think about the model of sewer collapse and sewer degradation, clearly something happens, a joint might open, might be a break, and then the force of the water behind the sewer, surcharging the sewer, heavy rainwater in the sewer, puts pressure on that weak spot, causes that weak spot to get larger and larger, more water leaving the sewer and greater ground erosion. That process takes time. Sometimes it can take weeks, sometimes months. We just happened to be in a spot where it happened exactly 2 weeks before us. We actually got fantastic data that we didn't even believe would be possible to get, which proved the value add of the data, the sensitivity of the sensor, and the ability to discriminate highly useful local environmental information as well as information about the pipe. That is the hole that was visible. That's what the residents complained about. To me and you, that's now conspicuous, isn't it? But imagine if we had data about that asset's activity 2 weeks, 2 months, years ahead of its actual occurrence, whether that's life longevity or whether a actual asset problem like that. So we did go and fix, as a company, we did go and fix that sewer. We would have fixed it anyway, but imagine if we'd have had information prior to that to tell us what was going on underground. We were only looking at our own water pipe, but that was a pivotal point in our understanding of the power and capability of this technology. It gave us true insight, which was truly staggering to us. I've worked in the water sector for many decades. I was staggered by this. This was an epiphany for me, and I was really grateful to have that bad luck on my project. Having said that, I will now hand over to Zahel, who's going to talk about the more normal type of data that we expected. So we actually gathered some really unexpected data, and I really want to emphasise that unexpected data was a godsend to us, and we really mined that and understood what it meant for us as an organisation. And it really gives us options that we never thought we had. So, Helen, I'd like to hand over to you.
Thank you so much, Steve. Thank you. As Steve has so articulately explained, pipe stresses are primarily from two conditions. A hydraulic condition, so that's really the primary point of stress. It's pressure that comes from the pipe. But there's also a geotechnical ground condition, the loading that happens on the pipe from the soil. And our sector has historically only really looked at one of those components in monitoring pressure and flow. We're pretty advanced in that now. We've got transient monitors, for example. But what Steve just described there was what is such a huge novel insight that we get from ground truth by being able to actually understand movements in soil and how that shifts around the pipe. As Steve mentioned, I'm going to talk to you a bit more about the data that we might all be a bit more familiar with, which is hydraulic transients. So these are events which frequently happen all across our network. And what you're looking at here is a 24-hour period that has occurred. This is high-speed pressure data from a section of pipe that we were monitoring using the ground truth system. And you see two events here, event A and event B. And they follow a relatively similar pattern. You've got a pressure spike and then a depressurization, and then again a pressure spike and another depressurization. One is of larger magnitude and one is of slightly smaller magnitude. And these happen at regular intervals throughout the day. We saw this, and this happens in every water network. It's just impossible to have a totally calm network with absolutely no transients at all. The challenge for utilities is understanding, well, what impact are these transients actually having on my main? To what extent are they reducing asset lifetime? Are there interventions that I can make that are cost effective, that mean that I don't have to go out and replace a huge section of pipeline? Can I install a slow release valve, for example, in order to normalize that pressure? And we were able to actually quantify that in asset lifetime for the first time. We were able to say, well, based on the pipe's response to this stress, and of course taking into account the soil conditions as well, and understanding how well that particular section of pipe was responding from a strain perspective, what would happen if we, for example, installed a valve that would get rid of the major peaks and troughs at event A and event B? So what's clearly happening here is we called it event A and event B because it's not clear whether this is somebody opening and closing a valve or what might be happening. We later found out that it was a hospital charging its well. And so clearly it's an event, an activity that needs to happen, but we just don't want it to be as hydraulically impactful. We don't want the stress to be as high as it is. And when you can normalize that stress, we were able to quantify in terms of the asset lifetime what it would bring back in terms of additionality. We were able to plot that on a stress strain curve because we could look at the impact of cyclic fatigue, these repeated stresses on the asset itself. We were able to then quantify the benefits from this system in terms that made sense in a water company context, relative to the balance sheet, relative to the P&L, because when you can extend the asset lifetime across a substantial portion of your asset base, you are effectively able to reduce these critical main failures. And in the context of, for example, raw water pipelines, pipelines which are, for example, 24 all the way potentially up to 48-inch diameter. These are particularly high stress or high criticality assets. And so a burst may cost you £1 million. So being able to deploy this type of system to mitigate that type of high impact is something that we were really, really excited about. And being able to extend the asset lifetime was such a key functionality of this technology that we were shooting towards, that being able to model the pipe in this way and understand the usefulness and the effectiveness of the actual algorithm that we had developed was something that was a really proud moment for all of us. So I'm going to pass you back over to Steve, and Steve's now going to talk a little bit about what this means from a water company context. Steve?
Thanks, Helen. So at this point then, we knew we had a very sensitive sensor. We had first rate analytics, and we were generating usable data. But how do we translate that into something we can actually employ and engage with in the organisation? So the data that was generated from our pipes that we'd put across our patch allowed Datatecnics to generate an asset health metric approach, which is represented in this graph. This is actually a very simple picture, but it's actually comprised of very, very rich data derived from real time. So I'll just walk you through that graph. You'll notice there's a green line high above. So that runs obviously left to right or across time, the y-axis. And on the x-axis, is time. On the y-axis is stress, represented by Young's modulus. So that represents the elasticity of the pipe. So the green line is actually in real time from one of our sites at Chorley, where initially on the left-hand side, there's nothing, because we haven't put the pipe in yet. We haven't put the strap the sensor around the pipe. Then at the point where there's vertical line, we'd installed the sensor. Shortly after that, for a few weeks, there is perturbance within the signal. That's actually a reflection of the sensitivity of the sensor picking up ground settlement from the excavation process and the compaction by the contractor and the revisiting by the contractor to actually resurface the road above the pipe and the sensor. That's how sensitive it is. Obviously, also, it's calibrating itself as part of its AI process to actually discriminate against noises and perturbance information coming in there. You'll notice after that initial perturbance, it settles down to a complete straight line. So that's showing us actually the pipe is quite stable. Nothing much happening, nothing much to report. In terms of its absolute position then, you'll notice that Datatecnics have very helpfully colour-coded the background of the graph, red, yellow and green. The line actually happens to sit in the green sector of that graph, high up in the Young's modulus, indicating that it's actually responsive to its stresses and strains. So in other words, it's elastic, it bounces back. You perturb that pipe, it bounces back. It's behaving very healthily. If that green line was positioned in the amber or in the red area, that would indicate that the pipe has lost its elasticity. It's lost its natural strength. It's lost its natural capability to resist strain and stress, and would actually be susceptible to problems like cracking and bursting. As it happens in this particular case, this pipe in Chorley happens to be objectively in the green zone. That tells us that it's actually behaving very, very well. In fact, in terms of the graph, because it's in such a high position, so it's so high up on the y-axis, it's actually behaving a bit like a 10-year-old pipe, which is great, until I tell you that that pipe's nearly 50 years old. Now, that is the first time we've ever had an objective measure of pipe health. That pipe was put in the ground nearly 50 years ago, and yet at this moment in time, when that reading was taken, it was sprightly, youthful, and behaving like a 10-year-old. We could theoretically now watch that pipe for the next 80 years and see it slowly pass through its natural life cycle of getting older and getting more decayed and passing into the amber zone and eventually passing into the red zone, at which point our descendants, not you and I, but our descendants will now have the choice of whether to dig that road up, dig that pipe out, refurbish it, replace it, reline it, in advance of catastrophic problems occurring, statistically speaking. As that pipe is actually in the green zone, that actually tells us important information as well. Our asset managers no longer have to be troubled by thinking about, do we make extraordinary investments or investigations at that pipe main in Chorley connecting to the hospital? Well, actually, no, it's behaving like a 10-year-old pipe, even though chronologically it's much older. That kind of powerful insight is the first time we've had an objective measure of health, objective measure based on physics, something that's actually replicable and based on rich data taken from real time. So we now have options about what we do with that kind of data. What do we do with this information? Well, as I said, we now have options. Theoretically, we could take that same kind of install, put it on our most critical mains, and then watch them to see objectively how are they currently at this moment in time. Are they really in the red, amber or green? And if they're anywhere where we don't want them to be, do we intervene? If they are where we want them to be, we can watch them until they change. We could even watch them for catastrophic single events that happen to them, as opposed to simply watching for their over time decay. So it gives us insights and surveillance of our asset stock like we've never ever had before. So we've now got options. And really, we've got questions from this then. What do we do to gather the best type of information over a wide area of a network? We now know what to do on discrete pipes, and that's great. But our learning was actually, how would we take this learning further and take it into a wider area of the business? And at that point, I'll hand over to Zahel to think of that perplexing conundrum in his own right.
Thank you, Steve. So we've had a real breakthrough. We've been able to understand on these critical mains what their rate of deterioration was, what their remaining useful life was. We were able to model them in a way that provided tremendous value to a water company. We were able to generate insights that hadn't been able to be generated before. But this holistic system that we had set out to achieve, this globally integrated platform of technologies that could understand all of the different potential and model all of the potential failures that were going to happen in a network, was something that we still had to shoot for. And as Steve has quite rightly said, we had lots of different directions that we could go down. But what was particularly interesting was we just started to ask ourselves the question, well, we had worked on delivering these remarkable strain models to critical mains. Well, could we deliver predictive maintenance type algorithms elsewhere? Could we build prediction models for asset health for the wider network? Could we think about different use cases for these prediction models, both in a strategic, i.e. multi-year, but also in a tactical and operational, i.e. in financial year mode? And that was something that was exciting to all of us at the time. And so around about this period, we started thinking about the ecosystem of tools that we wanted to develop, not just for critical mains, but all of the potential use cases within a water network context that we wanted to work through. And one of the conversations that we had was with the asset management team, who basically said to us, well, it's great that you're generating this really high quality, high resolution, high frequency data on specific lengths of main to model those specific lengths of main. Could you do much with the huge volume of data that we've got at the moment? Can you help us and work with us in order to enhance the models that we already have for asset management? Because we're getting ready for PR24. And that was something that I think really started to get us to think about the model that we wanted to build that would look at the whole network. And this was really meaningfully now starting to move us towards that ecosystem approach, really meaningfully allowing us to think not just about specific mains, but about modeling an entire infrastructure base. And so we undertook that exercise. The brief was to build a model to predict mains failure across the whole network. And that was something that we set off with. But as we always do, we want to understand what the value is that we're actually providing. It's not just about creating tools for the sake of creating tools. We wanted to understand what was the specific problem statement that we were solving, because we knew exactly what that was with ground truth. We knew that there was an old, aging asset base, which was really hard to model, critical mains, which needed to be understood. But when we were modeling the whole infrastructure, what models currently existed and what did they look like? And if we look out to the whole of our water sector today, most of the techniques that we use are highly manual, highly specialized, statistical techniques. There's very few examples of business as usual, machine learning, artificial intelligence-based predictive modeling across an entire infrastructure base. But it's a problem that's particularly well suited to artificial intelligence. AI is naturally suited to modeling such a large volume of historical data. And we presented that to you, and that was exactly the thing that they were excited by, because it wasn't just a case of applying AI. We could leverage data. We could create this foundational model that would use not just the static data, that it already exists, but also augment that data with dynamic time series data. All water companies around the world, or I should say most water companies around the world, also collect time series data from sensors. And so you want to really be able to understand both of these things. It's not just about the asset as it is in a particular point in time, its age, its material, its diameter, its length. It's about how that pipe section is evolving over time, because if you understand that, you can integrate that you can enhance your model to build a much more ultimately a better prediction of when it's going to fail, because you're taking ground truth, real world data. So we had to build that architecture, not just for static data, but dynamic data as well. And from that came a new tool, Failure Indicator. So Failure Indicator is an entirely software-only tool. And what it does is it takes all of the existing data, cleanses that data, and applies a series of artificial intelligence-based algorithms to make predictions of failure, likelihood of failure, across an entire network. And it presents these in a tremendously beautiful, tremendously simple format. So that was something that really helped achieve the brief that we wanted to. We wanted to evolve the models that were available, and we wanted to understand, well, how much more performant will this AI-based approach be relative to the standard statistical method, which can be very costly, very time intensive, can take weeks and months to refine those models. How can we do this instantaneously, on the fly, and critically ensure that these models were much more performant than those existing models? And when we applied this to a benchmark model of a water distribution network, we found that our models performed about 4 times more performant, i.e. they caught 4 times as many of the right failures over a defined time period when predicting for infrastructure failure. So that was a real validation of the usage of AI, and it was something that gives great encouragement to apply this problem to PR24 and supporting UU in putting together their business case. Water companies are now starting to think about the usage of machine learning for exactly these type of strategic asset management purposes. And this was a real validation of that approach. And we worked with the asset management team, who absolutely remarkably found that when these models were applied to their existing techniques, that our Datatecnics model had a 37% likelihood to avoid a further 37% of mains failures. So the Datatecnics model was projected to help you, in its own words, avoid a further 37% of mains failures compared to the traditional approach. If you think about avoiding that volume of failures, it's absolutely exceptional from a cost-saving perspective. So this was, as I said, a real validation of the technique and the approach, the usage of AI for these particular purposes. Having delivered this for PR24 and having had such a resounding success with the asset management team, 2023 comes along, and now we're at a point where we've delivered this remarkable capability for critical main management. We've built this software-only suite of algorithms to ingest and process at a strategic investment planning level, business case level, essentially which assets were going to fail over that 5-year period. But now it was a question of, okay, well, how can we really start to bring these tools to life? How can we drive operational, i.e. in financial year efficiencies? Because if you think about the other tools, you're making investments, although the knowledge is very powerful, you're ultimately making investments that are going to impact you beyond that financial year. You're replacing sections of pipe, you're building schemes that are going to be outside of a given financial year. Whereas we really wanted to think, could you use big data, could you use AI to drive operational enhancements? And the first place that we really started was thinking about a tactical tool to just build a map of the hotspots of failure within a whole water network. The idea here was, if you could visualize regions in your network that were particularly susceptible to burst, i.e. where the burst rate was higher than it ought to be after you've normalized for the pipe's material, its age, its diameter, then you could really end up in a position whereby network performance engineers can really start to conduct and have a powerful tool in their investigative arsenal. And that's what we delivered with the new XBurst tool. So XBurst was a method, again, at a software only level, of taking all of the data that we had available and then working with network performance engineers to say, we believe that your regions are either underperforming, overperforming, or on track, i.e. they have a higher burst rate, lesser burst rate, or an expected rate of bursts when you account for the pipe materials and the pipe properties of that region. We then went out to the field, we validated that with water network performance engineers, and we found that in every single one of the areas that we approached that there was a cause for further investigation. Some of these areas had already been rehabilitated, and those network performance engineers found that when they actually looked deeper into the not just burst performance, which was obviously known to them, but the hydraulic activity, that we had generated, again, novel insight about what was going on in their region. And some of this related to industrial demand, some of it related to new connections. It gave them a tool to investigate regions in their network which weren't just bursting at a higher than, like, these aren't just gross bursts. I think that's a really important thing to remember. We're not just looking at a table and saying, right, this region has the most bursts and then this one and this one. These are bursts that have been normalized, i.e. we've accounted for the fact that this is a pipe with cast iron material of a certain age. And so when we brought this back to asset management and we said to them that we had built this tactical tool, we were then able to get some figures for the cost of a given burst. And so we looked at just the top 20 areas, i.e. the top 20 DMAs, and we said how many bursts are occurring in those top 20 DMAs above and beyond what ought to be happening, what we would expect. And we're able to identify over £3 million of savings, potential savings, from possible interventions that we could make over that 2-year period by looking and aggregating all of these excess bursts. These bursts were happening above and beyond that baseline. And so that was a really powerful insight, because we were able to establish a quantitative business case, a means of identifying and focusing on these so-called hotspot areas where water companies could focus their efforts. You could look at those regions and say, this is where we can make meaningful change. So that was one step in the direction of operational enhancement, and that was hugely exciting. But there's another step here, and I'm going to introduce Courtney Connor from the leakage team to talk a bit more about the CEO challenge.
Well, a big part of my role as leakage technical manager here at UU is looking at continuous improvement. So how do we achieve our leakage targets, both in the short, medium and long term? The best and most exciting part of my role is when I get to work with the Innovation Lab, with the CEO Challenge. I'm working with suppliers and with ideas within that world of innovation. So I'm going to talk to you a little bit about the CEO Challenge 2023. So the CEO Challenge is an annual competition that we run at United Utilities. It's sponsored by our CEO. And it's where we bring our graduate population together to work in multidisciplinary teams over a 12-month period, focused on the key problems that our business are facing. They come together and they go from understanding that problem, doing research, all the way through to demonstrating the business benefits. And it culminates in a big competition finale where presentations are given in front of a wide audience within United Utilities, and the best team is voted for. So I was supporting Team 1, Find and Fix, as their business lead, and they were looking at, or they came to the final statement of, how can we better value and prioritise leaks to find and fix them more effectively? Within that, there were a number of focus areas, one of which was working with Datatecnics, and for me, that was the most exciting. So as we started to develop and think about what Datatecnics could do for us, we posed the challenge of, could we take a data analytics-led approach to our proactive leakage detection investigations so that we could become more efficient and effective? The answer was yes. So taking and building upon what Sahel has already talked to you about, failure indicator and experts, we set the challenge of building an application that our field technicians could use to help them reduce the time to find leaks. So within this, we were looking at how we could predict which assets were most likely to be leaking, then how we could group and organise those into a sensible and practical workflow for our technicians to follow, whether we could then prove the logic and find leaks following that, and ultimately, could we reduce the time to find those leaks of value? Whilst we were doing that and we were developing the application, we actually realised there were so many more insights that we would gain from what we were creating. So at the moment, our approach is fairly archaic in that we send technicians into an area and they work between both paper plans, which may not be entirely accurate, and also our live GIS system, but they don't have one view in which they can see GIS and respond to it and interact with it and update it. That is practical and friendly. So through developing the application, we realised we could start to collect information about the availability of our assets. How many are actually there? Are they available to be surveyed? We could gain insight into how accurate our GIS plans were, and we could then feed back updates. We started to get, for the first time, kind of a real insight into technician productivity and how many assets could be surveyed in a given time period, what would be the norm. And then ultimately, we were hoping to reduce the time it takes to find leaks. So, if we could consistently locate leaks of value within a survey, whilst we're surveying a whole DMA, we could be more efficient and effective with our finite detection resource. And then not only would that help us from a business as usual point of view to proactively go and detect leaks and improve our performance, linking back to our key strategic objectives as a company, but it would give us that ability when we have a region-wide incident, for example, a big freeze thaw, to better respond and recover. So here comes Sahel to talk about leak response and what was actually developed in the application.
Thank you, Courtney. So, leak response is really one of our most exciting projects. It really thanks in huge part to the wonderful team members who were part of the CEO Challenge, and in massive part thanks to Courtney's contribution, because she worked with us to really refine and tweak and augment in this really iterative approach what the visual language for this, ultimately this field tool that would help the leakage technicians out in the field get to exactly the right areas within the DMA that needed to be investigated to reduce that time to find and fix leaks. So we're able to take all of the data that we had already brought in, all of the static and hydraulic and dynamic data that was available to us from UU into this cloud environment where we were conducting the modeling. We're able to generate an entirely new algorithm. And so what you see here with leak response is this beautifully designed, really simple tool for field technicians to do two things. One, log exactly what they're doing for every sounding point, every survey point that they go to, and say whether or not they've heard any noises, whether they found any leaks, to collect any notes, provide that kind of real visibility of what's happening in the field. But then in addition to that, they now have an AI optimized and artificially intelligent optimized approach for as quickly as possible getting to the areas within a DMA that are most likely to be leaking. And we've really worked, it was the relationship that allowed us to build this type of tool, because we worked with the field technicians. We went with them into the field and actually saw how they were using the tool. We asked Courtney and her team for the feedback around how this tool would actually be used. And so, as I say, this is something that we're really, really proud of. And I'm going to pass back over to Courtney now to talk a bit more about what we found.
Thanks, Sahel. So in a relatively short period, a matter of weeks, Datatecnics did a fantastic job of developing the application and tweaking it to our feedback. Some really big asks to develop in such a short period of time. So when we started clustering and prioritising and making it practical for the technicians to follow the predictions, we then said, okay, well, what's the most efficient route to walk between those different clusters? What's the most efficient route to drive? And they built on things like tying into Google Directions and anything that we thought of that would make it easier and more useful for the technicians. Datatecnics were great at responding. And the development for me was just astounding, to go from nothing to what we had to trial. And as I say, that's the most exciting part of my job. We then did a relatively short period of testing, which we're very excited to say we're about to continue with. We surveyed 7 DMAs. We managed to find 893 assets. And actually an insight that we had, which was much better than we thought, there was relatively few assets that weren't either available to sound or were missing. In 100% of those DMAs, we found a leak within the first 25% of survey points undertaken, and that was over an 8-week period. As I said, we quite like to give a challenge to Datatecnics. And one of the things that we said would be really useful is, could we give the technicians an augmented live view of the network? So when you're walking down a street, what assets are you looking for? Where are you expecting them to be? That really helps, because as you can imagine, you're walking down a street and you might have cars parked over your target assets. And it'd be quite easy, if your plans aren't up to date, to walk by those. And we don't capture how many we aren't able to access. You might find assets that are in the ground that aren't on the plans. You might find ones that should be there that aren't there. So we have got this as a demo. It's something we're looking forward to developing in the next phase, as would be some other challenges that I haven't talked to Hale about just yet, but how we could do a post-DMA survey review. So a technician and online manager could visualise what was covered in a DMA, how we could prompt to use different detection techniques depending on the density or availability of assets. So we've got some exciting stuff coming, and I'm really pleased that we're continuing on the journey with Datatecnics.
Tripper. So thank you to the team so far for a great presentation. We are now just going to go to a quick 5-minute break. So get yourself some hot drinks, pop to the toilet, and keep popping your questions in the Q&A as we are on break, as we'll be coming back to a little bit more information about the future developments of Datatecnics, and going straight into the Q&A. So the time is now 12 minutes past 11. We'll be returning at 17 minutes past. Thanks, everyone. Hi everyone, and welcome back. We're going to hear a little bit more from Sahil now about the future developments of Datatecnics, and then we'll be going into our Q&A session. So welcome back, Sahil.
Thank you very much, Leah. So, there we go. Right, sorry, small clicker problem resolved. What you've heard today is a lot of collaboration, a lot of co-creation, working together. But one of the things that's absolutely indispensable is that when you're building any technology, any really successful enterprise, it's very important that you always understand what it is that you're solving for. Technology needs to be coupled directly to problem statements, and we couldn't have done that without United Utilities, working with them to define what those problem statements were. And in the bid to build a holistic, integrated, network-wide asset management platform to reduce water loss and to drive these huge efficiencies that we wanted to, we knew right from the start that no single technology, no single tool, no single algorithm was going to be able to model an entire asset base. Clearly, a pipe system is too interconnected and too complex. And so therefore, one of the things that was really key for us was to understand what each of those problem statements were, to define them, and then to allocate the best possible technology to them. What we created in the process was a unified, integrated architecture to collect all the data that we needed, to enhance that data with higher resolution, higher frequency data. We got it stored in the right place, cleansed it properly, and we modeled it across an entire asset base. And this is very much a start of that journey. We're really excited about where we're going to take this ecosystem of tools that we have built. But as I say, fundamentally, we haven't been able to get here on our own. You have helped us define the pain point. They've allowed us to really lean into our expertise with the multidisciplinary engineering and working with all of our tremendous experts, our remarkable staff who are incredibly knowledgeable and talented, and have allowed us to get to this very point. They have then verified that and backed it. That's really key. We needed their investment, we needed their support, we needed their commitment. We needed the brave champions, as we call them at UU. Everyone from directorship right through to the technicians on the ground that we work with for leak response. Everybody has been so massively collaborative with us. We then had to model that using best-in-class algorithms, and then we had to work with UU to really build trust in these tools. All of that needed to come together in a unified way, and none of that was ultimately going to be possible. None of this that you see, all these tools that we've been able to develop, would have been possible
if we hadn't have had any one of those components. And so I'm really pleased to say that we have developed 4 exceptional tools, high quality tools with the support of United Utilities to model different portions of the infrastructure, and we have more yet to come. And over the course of the last 6 years, in working with UU, in building it in these individual tool sets, we've been building our own internal architecture to take data from any given water network, to ingest that data, to process it, to structure it properly, and to predict for failure across the network, and to understand where sensor deployments and which types of sensor deployments, whether it's pressure sensors, flow sensors, strain sensors, or any of the other types of sensors that we deploy, where they're best deployed within the context of a water network. So it's really helps water companies move towards high resolution sensing and artificial intelligence, and we call that platform Foresight. And I'm really pleased that today this is the culmination of our efforts. This is what we can present to you as the platform that we are now rolling out to the wider water sector. And none of this would have been possible if we hadn't have worked with UU to co-create the tool set that we presented to you today. I'm going to leave you with a final thought, which is, as I mentioned earlier, technology, really good technology only gets built when you work collaboratively hand in hand with customers. It's really important to understand what the pain points are. But something that was said to us that never really left us was that ultimately we're custodians of our infrastructure. This infrastructure will far outlast all of our lifetimes. It will be here when we're not here, and it's really important for us to look after that infrastructure. And we feel really passionately about that at Datatecnics, and we're really proud, really pleased to have had a partner to support us over the course of the last 6 years in building the Foresight ecosystem. And with that, I'm going to pass you back over to John at UU.
Thank you, Sale, and thank you to all our speakers and everyone who's helped prepare this, including Spring. So hopefully you've heard quite a lot from us, but as you can see on the screen, what better than an endorsement from somebody who's going to potentially have to use this. So I won't read it out at length, but there's a quote there from one of our senior members of our business who've got the responsibility for planning and considering the strategy and committing to the strategy going forward. And as you can see, the work that we've done with Datatecnics over the years has really helped find an innovation that could potentially really help us going forward, not just for the next 5 years, but potentially the 10 years and that. But we're still excited to carry on with our plans and the journey to go forward. But overall, I just thought, as the finishing item before we go into Q&A, I thought I'd just touch base and just go back over some points that I thought that we've just gone through. So I hope through this process you've heard how the lab and the CEO challenge and some of our innovation ecosystem has helped us create and enable, empower difficult challenges that normally we won't be able to get through in this uncertain and challenging world that we live in. I hope you also heard how important it is to find and work with great partners in a collaborative way, and genuine collaboration is both hard and challenging, but ultimately an invaluable exercise for what we do. Key to that are the suppliers. Working with great suppliers isn't a given. So when you find great open innovators that are agile, are curious, that have that doability, that bounce back ability, that can help get through those challenges and use their intellect and their connections to really broaden and embrace what we need to do in innovation, it's a really important part of what we have to do to help us enable these benefits that will ultimately, as custodians of the Northwest, improve the place we live. Now, there was a phrase, brave champion, that was used earlier. Now, I hope that's a takeaway to everyone in the water sector, for example, that we have to be brave champions of difficult innovations. So we can't necessarily just step back and expect it to happen. We have to be there at the front edge. We need the Courtneys and the Steves of the world to be able to support and champion it, but also the John Burkheads and the other senior members within our business who've really helped sponsor this, all the way up to our exec, who've really supported and championed it with enthusiasm and trust to work through difficult and uncertain scenarios. That without, in a very risk-averse industry that could be perceived by some as quite slow, if without that brave sponsorship and championing, we'd never get there. So it's a massive thank you to all those unseen, unheard of people who've been involved in this journey as well. Now, on a little bit more of a nerdy note, there was a consistent thread going through here, and you might have heard the phrase problem statement. Understanding the problem can involve So one thing that I hope you've learned from this process is that a collaborative understanding of the problem and how you define it and how you refine it as the project or process goes on is really important as well. Because what we started out on day one isn't what we are at today. So it's important that you continue review and reflect those problem statements collaboratively as you go on. So my final part is a thank you to everyone involved in the process so far. And I believe we've got a selection of QA items to go through. So with no further ado, I want to say thank you. I'm excited.
Thanks, John. If all the speakers want to come join me in front of the camera, we'll now go into our Q&A session. I'm just going to stop sharing my slides so you can see all their lovely faces a little bit better.
Very cozy.
Perfect. Okay, so the first question I'd like to ask is, do you have any particular sort of learnings from this project that you would kind of improve if you were to do this project again?
Yeah, I'll take that one. We have a selection of lessons learned, and as part of any of our innovation processes and projects, we do reflections at intermittent points. So we've been doing this since the start of the LAW and all the way through. So some of the key reflections I've referenced brave champions. For me, that's one of the important things that we have to undertake as the host. From my perspective, I think that's the number one for me. Steve, Courtney, anything from your perspective from the hit list that you think you want to reflect on?
I think for me, it's how do we take the great successes of the lab, of the CEO challenge, and how do we then incorporate that into business as usual? And I think as a business, we're doing a great job of starting it, and we need to make it more fluid, how we can then adopt what we've developed and get the benefits as quickly as we can.
Perfect. Thank you, Courtney. Any reflections from Datatecnics in terms of learnings from the projects? Or
I think principally the major learning for us, the major value that we've always tried to adhere to is just be as agile and as flexible and listen as attentively as you possibly can, because these projects are fluid. They move, they shift, they change, they require you adapt to those difficulties as they come up. But if you do that, you can achieve great outcomes. So the learning really is just to remain as attentive as possible to the customer's needs and really take those into account when building technology.
So flexibility is sort of a key as a supplier in the situation.
Yeah, absolutely vital.
Absolutely. Great, thank you. So Andrea wanted to ask, I think it's one for you, Sahil, what is the longevity of these sensors? The graph you showed a period of a day. Are the predictions of the model accurate for longer periods?
Yeah, we built all of our hardware to last for at least an investment period, so at least an AMP period, knowing that that's the investment cycle. So that's at the moment what we've defined, because again, you're starting with problem statements, you're understanding what period you're modeling over, what value it's going to deliver. So you start with that and you design your technology in accordance with that. So at the moment, it's one specific asset management period, which for everybody who's not from the UK, Ireland, Scotland, that period is 5 years. So within a water company context.
Perfect. Okay. One from Josephine, I think for Sahil as well, and maybe Steve too. Have you considered vehicle movement, e.g. HGV, during off-peak and peak time as part of your design criterion? And have you got any graphs to show us the impact of traffic movement to your sensors?
So maybe I'll start and then you can add anything that you've got from this. But one of the really interesting, so we started at the Pennine Water Group, and the University of Sheffield were a wonderful partner to help us build the initial version of technology. But one of the things that we didn't mention is for the last 3 years, our research lab has been based out of the University of Exeter Centre for Water Systems, where we are taking pipes to failure, we're stressing them, we're putting them under various loading conditions. We had this one research project where we got a group of master students to apply a different series of AI models to the strain data we were collecting. And one of the things that they were simulating was how does a series of high goods vehicles, HGVs, impact the loading on the, heavy goods vehicles impact the loading on the pipe, and how does that change the asset lifetime? So we were simulating, because the ground is such an important factor in creating deterioration of these pipes. And so it's actually something that we've looked at. It's something that we've modeled and incorporated for. So yeah, I mean, I think there's one of the things that excites me the most about ground truth is that there are so many niche use cases. I mean, to tease that out a little bit, I had a conversation with a water company in the US who said that there were boring machines that were making their way through the tunnel to create these bores, these tunnels under the ground, and they were having a big impact on the way that soil moved and therefore creating further stress on the water infrastructure. That was a use case that we'd never even thought of, you know. So I think when you start to model and reveal this underground environment, it's really exciting. If you've got anything to add to that.
And just add to that, well, just building on that and actually getting a bit more of a underbelly understanding of the technology. We've obviously got a sensor, which is quite coarse, really, when you think about it, and quite physics based. The clever part of this whole exercise is actually in the analysis, the AI in the background, the actual discrimination of that data. And you're quite right. Road traffic is one source of noise, one of many sources of noise, which would otherwise overwhelm any system that wasn't actually looking out for the difference between background noise and real important information. So part of my learning of this whole journey is that the sensor is one part, and that's fine, but the actual algorithm behind the scenes, which actually learns what is able to be discriminated, what is able to be discounted, and yet still keep enough sensitivity to actually give us insights into phenomena which we may not even be expecting to occur, is actually part of the offering that we've received here. So your question about how do we factor in Lewis and such like, well, we know that they're part of life, and we know that that's part of the early degradation of assets. And in London, they claim that, you know, the heavy traffic that wasn't intended when the Victorians built those pipes has caused and contributed to premature failure of some assets. And so we know that as an anecdotal fact. As I say, for the first time, we've actually been able to have data-based understanding of what that phenomenon is. So in terms of the question, the approach is really that we've got a fine resolution on the various contributors, including vehicle movements. But we also know that ground stress, ground movement, even the moisture content of ground as it changes across the seasons, puts what had been previously known but not real-time measured strains on our pipes. So all through this process, we're just gathering more and more information on what's really pertinent to our understanding of our long-term asset stewardship of these underground assets. So good question. Hope we give a satisfactory answer, but I think your question actually belies more and more questions when you actually follow that thread through.
Absolutely. Thank you, Steve. Question from Harvey, I think for Sahil too. How wide an area does the sensor pick up? Subsidence detection could be very useful for other sectors.
Sorry, could you repeat the question?
Yes, absolutely. How wide an area does the sensor pick up?
Yeah, great, really good question, actually. So the very first iterations of this, because they're such a small gauge, they're really only able to determine shifts within a relatively small confine, what we call a boundary box condition. So we've circumscribed that, and in the very earliest versions of this technology, we were looking at a relatively small, as I say, boundary box condition. It was only about 2 meters cube. So clearly, when you're trying to then infer what's happening across a full length of pipe, that's in and of itself not particularly useful. So that was one of the earlier challenges that we grapple with, and where we've been able to evolve that thinking rather than try and have individual, what are called boundary boxes, individual sections of pipe that we're monitoring. What we're now doing is we're actually modeling the entire asset length using a series of physical numerical equations that allow us to understand what the behavior of this pipe, given its elevation and its hydraulics and its soil conditions, ought to be, using various data that we collect. And then we calibrate this digital model, this numerical model, this physics-based model with the strain data, and we then make inferences about what's happening along the length. So it's a small, or seemingly small, but incredibly important shift in the perception of the technology. So we can understand what's happening at a local level, but ultimately, if the point is to understand what remaining useful life and the likely rate of deterioration is across the length of the main, then we can't just take strain data in isolation and build an algorithm to just look at what's happening in this small, 2 meter cube boundary box condition. We need to find other means of including and incorporating data that allow us to model the length of pipe. So yeah, really good question.
Perfect, thanks, Hale. Another one for you, I think, and Steve, from Roy. Could you please elaborate on integration with United Utilities OT, IT digital infrastructure with the new IoT digital system?
Yeah, I mean, I think there's two things here. One is that there's a difference between when you're piloting versus in a commercial setting. That's something that's really important to bring out. And then the other is the strategy that the water company has, that any given water company has for itself, based on its security processes and policies. So I won't talk to the second of those because those are UU specific and codified in its strategy and documentation. But with respect to the first of those, for us, it was a relatively straightforward exercise, so long as we could demonstrate that we were an organization that was fit to handle data. So we went through all of the relevant cybersecurity processes and policies. We got audited by the internal UU teams to ensure that we could handle that data safely and securely. And then we were allowed to model some of the data and providing obviously assurances about where we would keep that data. So a pilot setting is very different to a commercial setting, and a lot of the work that we're doing now is to resolve exactly that latter point that you've raised. So hopefully that it touches on some of the key differences between a pilot and a commercial setting.
Yeah, absolutely. Thank you. So next question is from Amelia, who wants to know, how is variability in pipe condition across monitored lengths addressed?
I'm going to assume that I think this is largely touching on some of the same points that was raised earlier around those boundary box conditions and how that changes along the pipe length. So hopefully I've answered most of that already, but it's definitely the case that you can't instrument. It's just not feasible, nor would you want to, from an economic perspective, to instrument, full networks with all of this kit. It's just, you can't be digging holes everywhere. You can't be putting, these sensors on every bit of kit. You can't. It's really difficult to handle that volume of data. So you have to come up with techniques to interpolate, to fill where the gaps are, and recognize that despite there being some uncertainty in the model, it's such a substantive step forward already that you can work with that relatively small amount of uncertainty in your model.
Brilliant, thank you. Not sure if you've already touched on this in answer to a previous question, but Harvey would like to know how many sensors are actually needed to monitor a pipe, what's the sort of spacing that you need in between them. Does the pipe need to be dug up, or can the sensor be fixed on the pipe?
So we have a general rule of thumb, but it will depend ultimately on the pipe's soil condition, its change in elevation, its diameter, its material, all of these things impact, even the use case that we're monitoring for, because it's here at UU we've had a very particular use case with PVC pipes, but at other water companies there have been other use cases that have necessitated denser measurements. In fact, we've actually repeated the exact same installation of sensors in a single trench right next to that same. We've just doubled the amount of sensors in the same trench for a very specific reason. So I'd love to be able to just give a single guide or a rule of thumb, but it's very much dependent on the specifics of that pipe. And I think that's really where our water engineering expertise is so valuable, because we've got really exceptional a really exceptional water engineering team who understand pipe mechanics, geotechnical mechanics. They understand how ultimately different pipe materials behave and corrode over time. And so for us, working with our internal teams, we're able to come up with the most appropriate deployment methodology.
Brilliant. So it's definitely sort of a case by case basis.
We have guides, rules of thumb, rules of thumbs. Don't know what the appropriate way to
Rules of thumb.
Yeah, there we go. We'll go with that. We have general guides, but there isn't, and I don't think it's for these critical mains. We would want to be in a position where we just run it through a model and just say this is always going to be, without any human intervention, exactly where it needs to be. I think we'll move towards something that's semi-autonomous, where we have some guides based on the modeling that we do, where the instrumentation should go, where the sensors should go, that takes us farther forward. But I think ultimately we will always want to have that water engineering expertise applied to it.
Amazing, thank you. Another one from Harvey is, I assume this can work with other utility pipes. How can you collaborate with other organisations that dig up the ground?
I feel horrible just hogging up all of the air.
Shall I give you a break?
Yeah. Well, I mean, I'd love to hear how you might think. I've got my view on this, but it'd be interesting to hear.
Well, it resolves to basic physics. So any pipe that has a Young's modulus, any pipe that has flexation caused by pressure can benefit from this. So that could be high pressure gas mains, rising mains in sewers and such like. So it is applicable to other sectors. Bizarrely, it probably doesn't apply to us in asbestos cement because it doesn't have a Young's modulus. So it's material specific. So yes, it can and should be rolled out. I think we'd actually want to start with our own water sector. So it's currently being used in the United Utilities, and I think a few other select water companies across the country, and one or two overseas as well. Or if I was your marketing manager, several overseas, I'd say, but overseas. So it's moving outwards. I think actually what we want is almost like saturation in the UK. Actually, let's get the benefits of this disseminated among our colleagues. So although you've seen a presentation today about you doing all this effort with Datatecnics, we've been doing it for ourselves, but also on behalf of the water sector in general, to be fair. So I think it should be rolled out to those. And Harvey, I think it's a great point you make about how do we then collaborate with other sector providers. Probably we will look at gas because we always look at gas for inspiration from them to bring technologies in. It might be useful if we can reciprocate that on one occasion and actually start to send something out. But I'll now having given Zahel a breather, I'll hand over to him with his marketing hat on and see whether he wants to actually penetrate those future markets. But a great question, Harvey, a great widening of the thinking process. Thank you.
Yeah, really interestingly, oil and gas in some aspects are, significantly farther forward. And, fibre optic has been the absolute creme de la creme of monitoring standards for the oil and gas sector now for, at least 2 decades. There's been deployments of this type of technology, of fibre optic monitoring, which a fibre cable allows you to conduct strain-based monitoring of an asset, but along full continuous lengths. So there are applications like this in other sectors. We love and fully buy into a future in which infrastructure monitoring is done using full-length fibre for various reasons that I won't go into now. So strain is just a really interesting parameter to monitor. It tells us so many things that we don't just get from high-speed pressure, which is, perhaps we would say the absolute kind of the high resolution sensing that we do in this sector. So we're modeling an entirely new parameter, but there's applications in lots of different things. I think that's, as I say, that's one of the things about ground truths that is so exciting for me, that it's not just in the water sector. There are other high stress pipe-based applications like rising mains, even in the water sector, that we could apply ourselves to.
Amazing, thank you. Amelia has asked another question and would like to know, was internal fitting considered?
It was, and it's a veritable RAS nightmare and electronics nightmare. So yeah, it's definitely useful to think of, and actually really suitable for another technology group. But for the current method of instrumentation, the current electronic system that we have, it's just it's not a feasible approach. I think the idea of putting something on a pipe was challenging enough. The idea of putting something in a pipe would have made people fall off.
Just for those who aren't aware of what RAS approval is, that's our rating on whether we can have potable water and the material is suitable for potable water. So putting any of our technologies into assets that might be used in a potable water scenario has a number of considerations that we'd have to make. Sure that the technology is suitable and does not create a detriment to our longer term asset. Purely in the simple case, we're passing water through, and therefore we don't want it to create any pollution. So that was probably the first thing that went, oh, maybe we should do it external. So as you said, a veritable nightmare, and it's a valid and important process to do it, the RAS approval process, but for the purpose of what we were trying to achieve with this project, it was one of those hurdles where, well, if we can very quickly avoid that problem, let's take that route instead.
Amazing, thank you, John. Trevor has asked another question and would like to know, have you estimated how this would compare at finding leaks with real-time water balance from perfect universal metering?
We have theorized it. We haven't actually run this in practice, but it's looking at because obviously one of the EPA scores is based on supply demand balancing. So we're really interested in how we can integrate our leakage tools to be effective against those EPA measures, but nothing in I think substantive detail.
Perfect, thank you. And then a question from Oliver: have you had any real world trials of application on waste rising mains?
Watch this space.
Perfect. Is that kind of included in what you were saying is looking to be launched at the end of 2024?
More details coming soon.
No comment yet. Okay, perfect. Okay.
Definitely something of big interest to us.
Great. Okay, perfect. John and Steve, from a United Utilities perspective, were there any sort of major obstacles that you encountered during this kind of partnership or project, and sort of how were they overcome?
Okay, so one was touched upon earlier, and I've got to give my hats off to both the UU side and the Datatecnics side. And when it comes to data and IT security, that is always a challenge, and we are coming under increasing threats from external parties and bodies who are trying to get access to our data and our systems. So, of course, we are absolutely at the forefront of trying to make sure we are secure and safe. But as part of that process, that means there are new things that have to be done and tested and checked. So as you're going along the journey, as things get updated and rechecked, we've got to make sure that our data and our protocols and our systems are all suitable and up to date for that. Now, I wouldn't describe them as any problems, but part of that challenge was this can not be just to be a moving beast, but we have to make sure we're ticking those boxes. And it required a lot of repetition of the message, saying, yes, we've gone through this, yes, we've done that, and thank you, we've done this. And it's part of that immediate concern whenever you mention anyone. Data, it's even in the title, isn't it? Datatecnics. As soon as data comes on, that's a red flag risk. So for us, from my perspective, that was one of the probably more high level challenges when it came to the project. But if we were in a idyllic utopia where we didn't have such security threats, perhaps we would be able to do this quicker. But in the reality where we live, we don't have that luxury, so therefore we have to do the right thing. And as Sale said, absolutely kept the ship in order, doing the right thing at the right time. But it was no mean task.
Perfect, thanks, John. And how about you, Steve? Do you have anything too?
Yeah, I think one of the biggest challenges is actually getting people's hearts and minds brought round to the idea. So within the innovation world, we're quite comfortable with seeing extraordinary things out of our normal horizon. When you're talking to other people in the business, they sometimes make that's the right noises, but you know they're not technically fully engaged. And it's our job to actually carry them along, which is great while things are going well. But when things aren't going quite so well, or the slow progress, it's easy for those kind of people to not necessarily follow their initial enthusiasm. So us keeping that enthusiasm buoyant has been a big challenge. Having an articulate speaker with technical prowess at our side has been a big advantage in that challenge. It's at some points you can imagine a situation where it's quite easy for people who are remote and detached from the situation to feel it could be another project we could close down or save money on or such like.
Absolutely.
And that's human nature. That's not reflection. That's simply the case. And it does make you think the amount of effort, personal, as well as intellectual, as well as technical, that has to go into these things. So the technical issues are probably the smaller part of the equation. I think we found that the managerial, convincing, propagandizing in the nice sense of the word, actually pushing the message out to people and keeping that message alive was a bigger challenge than I anticipated for a technology that on the face of it speaks for itself, but we can't assume that. So to me, that's a bigger challenge, actually keeping our own people engaged and fully bought in at all stages of the journey. And certainly something we can take away from that and learn on other projects. So yeah, a very good question. I hope it was a good answer.
Yeah, absolutely, absolutely. So would you say if, say, a water company wanted to implement the same project, you would recommend getting sort of a communications team involved to kind of keep those messages going and keep people engaged?
I think we all initiate communications. I think it's the sustaining the course, which is the lesson that I take away from this. We're very good at initiating communications and lining that up. But when you're on a long-term endeavour, and this is a long-term endeavour to fundamentally reappraise how we actually address our asset base. These assets are on the ground for hundreds of years, so we shouldn't expect things to happen overnight on these developments.
Absolutely.
We all want speed. but nevertheless, let's keep it real. These things are long-term systemic changes that we're trying to promote,
Yeah.
and therefore we need a long-term systemic communications plan to support that. And that's probably something that we probably didn't anticipate to start with. We just thought that the early successes would carry the process on, and within our community they did. As I say, it was easy to lose touch with the influencers and the higher senior stakeholders. Don't get me wrong, we got support as we needed it, but it was always, we could always put more effort in. I think we should in the future.
Yeah.
So
Can I jump in?
and there's a core bit when you come to about communication and messaging, and one of the bits that I find challenging with most innovation projects, in particular, if this brings it to life, in what's the benefit, what's the value? When you step and look at it and go, right, what value does it bring to us? Well, if you look at it and read and go through the material, well, you can kind of see this would be useful. Then the real challenge is, how do you quantify it? How do you really quantify that in the short, medium, and long term? That's a perpetual problem everywhere. But when you add data into it and how you then quantify the challenge of getting over those hurdles and then rolling it out, being able to quantify and demonstrate the benefit is really difficult. As we probably all know, when we're all doing all our various innovation projects in general, quantifying the benefit is difficult. And this is an example where it can be, if you get the messaging right with the right stakeholders, it can be hugely effective and influential. But that's not saying we got it right first time. But as we were progressing through that journey, reflecting against that problem statement, making sure we were able to communicate against that problem statement, being able to demonstrate that benefit is one of those core messages. If it was a lesson learned to take away, it might not necessarily have the answer on day one, but have it on the mindset going, how are we going to be able to demonstrate the benefit? And it isn't just pounds and pence, it's time, it's health and safety, it's environmental, it's all of that ecosystem. Being able to try and quantify that, or at least value it as you go through that process, is difficult. Shouldn't necessarily be an immediate blocker at the beginning, but it's something that you need to work through as you go on. Because if you don't, and you get to the end and you haven't thought about it, it makes that sell really hard.
Yeah.
So it sounds really obvious to do, but it is an important
But it's
factor.
surprisingly not. This is the crazy thing. Like, you're right. It seems obvious, and one would think to do it, but you have to really work at it. Right?
You have to work really hard to make it, to understand it, to quantify it, and you've got to have a deep understanding of an individual business, because a benefit to one company might be different to another company because they do it in a different way. So being able to quantify that benefit for the sector and for the business is a difficult challenge, but I think that's where good collaboration, good communication between businesses and stakeholders is important. Being able to demonstrate that benefit, reverting back, is a challenge of all.
Absolutely, thank you so much.
Sorry, so you were going to say something. You had a point.
I mean, it's exactly that, but just in a different vein. It was just like, I think we, on some level, definitely took it for granted that when we came with what we thought was a technological response to a seemingly technological problem, that we didn't couch it enough in the business problem and therefore the business benefit. So we didn't do that translation exercise enough in the start, right? We didn't, because we were new to the space, and we didn't we were so focused on delivering this technology solution that we just thought, oh, it must be so obvious what that benefit looks like, but it's not. And you have to work really hard. Both parties have to work really hard to then be able to communicate that, quantify that, and then people say, oh no, of course, like this is something that we should be doing. And I think that's something that you could see the evolution of that, and I think we really nailed that with leak response in particular, where the actual person who's going to be using and owning and managing the product on a day-to-day basis was the person doing that quantification almost in real time. So yeah, I think it's just such an important point. It doesn't happen organically. You need to work at it.
Absolutely, and it's important to look at the sort of broader business perspective as well as just your particular technological perspective, sort of thing. Absolutely. Okay, great. I think Trevor also just wanted to ask if you'll be publishing a directory of brave champions.
I can talk about all of the people that I think are rock stars in the sector. So, Trevor, if you want to hit me up, I'll give you that list of rock stars. No problem.
Amazing. Perfect. Okay, well, I think that brings us to the end of our questions. If you do get any more questions, feel free to get in touch with either Spring, with myself, or with Zahil, or John, or Steve. And thank you to everybody for coming today. I hope you've enjoyed the session and found it interesting. I know that I have. And thank you to the presenters for all the hard work that has gone into today's presentation. I think it was a really, really interesting one. There's just been a poll launched in our chat asking the audience how interesting you found the session. So if you could let us know, it's always really valuable feedback for us moving forward with these showcases. I just want to say thanks again to the audience for attending today, and a final thanks to the presenters. And thank you, everyone. Bye.
Thank you very much.